based on just you guys. So it looks like there's not a lot of people today, but today we're working on the section 1 part B, as you guys can see, and I'm just kind of going over any questions that you have so far that have come up while you're working on the multiple choice. So if you have any questions, please feel free to ask. If you don't have any questions, I'm just going to be waiting around a bit to give people time to log on and things like that. But again, if you have any questions, please ask them in the calculus and questions section. Okay, so we have a few questions coming in. So I'm going to start with number 4. Number 4. So let's do that. So starting with number 4, let me grab this. Okay, so first off, I want to remind you this is calculator stuff, so you are allowed to use a calculator. So just kind of be aware of that, because some of these you might be looking at, how do I integrate this? You don't have to worry about it. So let's see what we have. We are told that g of 1 equals 2, and then we're supposed to find g of 5. So what I'm going to do is I'm going to do the following. So g is the antiderivative of f of x. So I'm going to say g of 1, so actually let me step back a sec. G of 5 equals g of 1 plus the displacement from 1 to 5 of our f of x function. Okay, so in this case, I'm going to say g of 1 equals 2 plus our definite integral from 1 to 5 of this function. From here, this is all calculator stuff. Okay, so this is all calculator stuff from here. Okay, so first part is, here's why. So there's a couple questions here and they're both related. One is, I don't understand why you add g of 1. And the second one is, why does it equal that? Okay. So think about when we integrate, what it does, right? So if I have a velocity function, it gives me a position. So let's just do a quick little graph. Again, not accurate, but let's do a quick little graph. And I want to go and find the displacement. So this right here represents the displacement, right? The change in position from time 1 to time 5. Okay? So in the beginning of this function, they tell us at g of 1 equals 2. So I happen to know at g of 1, the height of this particle, or whatever it is at 2. What my goal is to figure out, what is it at 5? So, right, what is g of 5? So what is this point right here, kind of? Well, in order to do this, think about it. If all I do is integrate the highlighted piece, right, then all I'm doing is finding this change in y. But it's not telling me, that's going to give me the height of this dotted line. Okay, that's all it gives me. But I want to know the total height from here to here. So in other words, I need to take where I start, right? I need to take this, which is at a height of 2, and I have to add to it the displacement, okay, that definite integral. So again, I start with 2 and I add the change from 1 to 5, that displacement from 1 to 5. Okay? In regards to number 4, do you have any follow-ups? Again, number 4. By the way, I think the answer for that is D. The question is, do you use substitution? And the answer is no. I am going to plug this into my calculator. Your calculator has the ability to do this. You can do definite integrals. So I literally am going to go and plug into my calculator 2 plus that integral. Okay, so my calculator and all your calculators can do this. Okay. Again, this is a calculator section, so I'm going to use a calculator. Especially because it's a lot faster, and in a lot of times you won't even be able to integrate them by hand. Okay. In regards to number 4, are there any other questions? I might be able to talk you through the calculator part if you're having difficulty with the calculator part, but it might be kind of hard, just obviously because we have different calculators. Okay. Next, same part. Why wouldn't you take an indefinite integral, find the equation of g, and then substitute? Okay, there's a couple reasons. So there's a couple reasons. First off, a lot of the calculators aren't going to do indefinite integrals. If you have, unless you have an NSPIRE or an 89, it won't even do the indefinite integral. So that's not going to be even an option for probably most of you. Some of you can do indefinite integrals. And I could do that. So if my calculator does do indefinite integrals, I can do the indefinite integral, use the fact that g of 1 equals 2, so I can plug that point in so I can find my value of c and then evaluate it at 5. I absolutely can do that. But remember, that's only going to work if your calculator does indefinite integrals, and that's NSPIRE CAS 89. So if you don't have one of those, that's what you have to do. And this is, if you notice, I think this is easier. I think what I've done here is quite a bit easier. There's no solving. I'm just going to literally plug this into my calculator. But again, the other way would work. Okay? Any other follow-ups in regards to number 4? Okay, so I'm going to skip around here a little bit just to kind of make sure I'm answering different people's questions, and then I'll come back to the ones that are listed there. So let's go and do number 2. Let's do number 2. Okay, so water is pumped into an empty tank at this rate. So notice this is a velocity function. Gallons per minute. Approximately how many gallons have been pumped in the first 5 minutes? So this is the displacement question, because they're not saying this is how many gallons there are in here at this time, how many gallons in total. They're just asking how many gallons are pumped from time 0 to time 5. So what am I going to do? I am going to integrate this function from 0 to 5 of this. And again, full-on calculator question. Okay? Full-on calculator question. Whatever this number comes out to be, that's our answer. Okay? In regards to number 2, do you have any follow-ups? Also, why that's coming in, while the questions are coming in, the question was asked, are we not going to go over 10 from the free response today? That is correct. I'm doing 10 from the free response on Wednesday. Okay? I won't have time today just because I have a meeting at 10:30. Okay, let's go to number 6. Let's go to number 6. And I'm going to grab this one again. Just be aware, I'm hoping I don't crash, but I'm kind of thinking I will today. There's kind of a lot of stuff going on today in this area in here. So hopefully I won't. Okay, let's see what we got. A particle is moving along a curve given by this. So this is the curve that it's moving along in such a way that the rate of change of x with respect to t is negative 2 at at all times t greater than 0. Okay? That's fine. At the point x equals 1, dy dt equals what? Okay. So let's see what we can do here. So we have this position function, y equals 2x minus ln of x. Oh, my thing's crashing a little bit. Not that. Okay. And what we're asked to do is we're supposed to take the derivative of this, but we're supposed to do it with respect to t. Okay, so everything we're taking the derivative is with respect to t. So let's go and do that. I take the derivative of y, I get dy dt, right? I'm doing it with respect to t, equals 2 times the derivative of x, which is dx dt, minus, we're going to take the natural log of x. So this one I'm going to have to apply chain rule on, right? So this is going to be 1 over x times the derivative of x, which is dx dt. Before I finish this one, right, are there any questions on taking the derivative with respect to t in question 6? Okay, then let's plug in our stuff here. So what do we have here? We're asked to find dy dt, and that's going to equal 2 times dx dt, which is negative 2, minus 1 over x, where x is 1 times negative 2. So that's a number, and we can clean up that number. In regards to number 6, do you have any questions? The reason I knew to solve it implicitly, so again, the question was asked, how do I know to solve it implicitly? This was my hint right here. They're telling me, notice the d, well, actually, it's not even that. This is my hint right here. Notice what they're saying. Yeah, it's because it's in terms of t, because it's dx dt, I'm taking the derivative, so the denominator tells me what I'm taking the derivative, what letter I'm taking the derivative with respect to. I'm taking it with respect to t, but of course I only have x's and y's. So that's how I know how to do it implicitly, and I'm specifically doing it with respect to t. Okay? Let's keep on going here. So let's do number 3. Kind of skipping around a bit here. Whoops, this is the wrong thing. So first off, let's make sure we're okay with notation. This is asking us to take the second derivative. Okay, so we are being asked to take the second derivative of this function. Now, some of your calculators will just do it. If you have an 89 Nspire, then you're just going to take this thing and take the derivative of it twice. Easy peasy. If you don't, right, if you have like my calculator, the Casio, then you're going to have to do this by hand. It's not a big deal, but that's what we're going to have to do. So I'm going to go and take the derivative of this twice. So first off, I get dy dx equals, so let's see, take the derivative of the numerator, which is 1, times the denominator, minus the derivative of the denominator, which is 1, times the numerator, all over the denominator squared. You should be simplifying. Okay, so with these, you want to simplify because it's going to be a lot easier, less mistakes. So I get x minus 1 minus x minus 3 over x minus 1 squared, which equals, looks like the x's cancel each other out. So I get negative 4 on top. I'm going to double check that before I move on, just to make sure I didn't make a careless error here. So let's double check. Hopefully the derivative is right. So I took the derivative of the numerator, which is 1, times that, minus the derivative of the denominator. That looks good. Perfect. Then it comes x minus 1 minus x minus 3. That is correct. Looks good so far. Okay. Next, so that gives me dy dx, but of course we're asked to find the second derivative, so I'm going to have to take the derivative again. Now in this case, I'm going to rewrite this because I think it's going to be a little bit easier. So I'll be taking the derivative of this function. Just because I think this is, like I said, I think this will be a little bit easier. Okay? So I'm going to take the derivative of this so that I can use what's it called? Chain rule. I'll answer your question in just a minute, but let me finish this up. Let me finish this up here. So let's see what we get here. So from here, applying the chain rule, I get negative 4 times negative 2 is positive 8. X minus 1, lower the denominator by 1, or the exponent by 1, so negative 3. So we get 8 over x minus 1 cubed. Okay, so let's go through some questions on that. So one question was, why wouldn't you cancel out the denominator for the first derivative? There's nothing to cancel out. I have to have a common factor in both. There is no common factors that I can cancel out from top and bottom. If you're talking about here, and I could be wrong, but if this is where you're talking about, x minus 1 would have to be in both. It has to be a factor, something that's multiplied to all three terms, which it's not. It's only in 2, so you're not allowed to do that algebraically. Okay? In any other questions that you have in regards to number 3? Okay, let's move on to number 8. Oops. Okay, what do we got here? Given, we have this function, find the value of a. Let's see what we can do here. Okay, so we are told that 5x cubed plus 40 equals this. Okay, so what I'm going to do, I'm going to play around with this a little bit. And you'll kind of see why, hopefully, in a minute. And this is definitely one of those ones that probably students would miss. It's kind of, maybe you would, but it's maybe a little bit harder. So what I'm going to do is I'm going to take the derivative of both sides. So if I take the derivative of the left-hand side, I get 15x squared equals f of x, right? That's the second fundamental theorem of calculus. Yeah, equals this. Am I doing a definite? Yeah, I'm doing a definite integral. That's a to x. So I get f of x. So now, here's what this tells me. So what I'm going to do now is I'm going to, remember, these two things are equal. And this is the big thing that I want to ensure. These two things are equal. So now what I'm going to do, and it may seem a little silly, but I'm going to integrate my 15x squared, right? Which we, of course, know the answer to. That's 5x cubed plus some c. Now, so what I have here at this point, these two things are equal. So what I want to do now is I want to say, and give me a second here. Let me think this one through for just a second because I just had it and then I lost it. Oh, let me rephrase that. Let's see. Hold on a second. You know what? Let me come back to this one because I have it, but I don't have it yet. So I know where this is going. Let's see. I just don't want to take your guys' time while I'm doing this because I don't want this thing to crash while I'm doing it. So let me I'm going to come back to this one. I may just need to work it out on my own first, just so that I can explain it. So like I said, I'm going to come back to number 8, but let's see this question. Why wouldn't you take an indefinite integral, find the equation of g, then substitute 5 in for x? Why wouldn't you take an indefinite integral? I'm not sure what you're taking an indefinite. Am I looking at the right problem? I feel like I might be looking at the wrong. Oh, I think I am. I'm sorry. I'm definitely sorry. I was looking in the wrong. I'm sorry. I was looking in the wrong part of the Discord. I hadn't scrolled down. Yeah. Let's see. Why isn't it? So the reason it isn't f of x minus f of a is actually it is. I am wrong. I don't know why I thought I was taking derivative. That's why I'm confused here. You are absolutely right. It is f of x minus f of a. That is correct. That's why I'm confused here. Because for some reason I thought I was taking a okay. It is and it isn't. So let's back up just a little bit. So, like I said, I'm going to probably have to come back to this one because I have to think about it. But let's just start from a couple things, and maybe this will help you guys out while you're doing it. So again, the first thing I'm going to do is I'm going to take the derivative, like I did here. So I'm going to take the derivative of this, and I get 15x squared. Okay, so now I know, right? I know that if I take the derivative of the right-hand side, I think you guys would agree. When I go to take the derivative of the right-hand side, I get f of x. Again, the reason I get f of x, not f of x minus a, is I'm not integrating this. I'm taking the derivative. So just one more time to make sure this is clear, which it may or may not be. The first thing I've decided to do is I've decided to take the derivative of both sides. Because if they're both equal, then their derivatives are going to be equal. So when I take the derivative of the left-hand side, I get 15x squared. When I take the derivative of the right-hand side, I get f of x. Okay? So what this tells me is, well, that's the first part. So again, that's this right here, the way I evaluate that, this is the second fundamental theorem of calculus when I go and do that. So like I said, I want to hold off on now. Actually, hold on. No. I think I got it now. Okay. So let's go back here. So now I have these two functions. And what I'm going to like I said, let me come back to it. I'm just not seeing it quite yet. I will see it, but I'm not seeing it right now. So I will come back to this one. I'm just approaching it wrong, and I don't know why. Okay, let's keep on going here then. Let's look at number 12. Let's look at number 12. Yep. I may save that one that I'm having a little difficulty with. I may save it. I may just do it tomorrow after I've gotten a chance to go and do it myself. Because I'm not, like I said, I'm not seeing it on my own yet. Okay, actually I think I may have room here. The function f and g are defined from 0 to b by f of x equals cosine 2 of x, g of x equals this. They will have the same average value if b is blank. Okay, I am going to grab this. I don't know if I'm going to need more room, but let me grab it just in case. Just in case. Okay, so one more time. The functions f and g are defined on the closed interval from 0 to b. F of x equals this, and g of x equals this. They will have the same average value if B is what? So average value, that's a flashcard. So I'm going to say we're looking at the average value from 0 to B of each function. So first function is f of x, which is cosine of 2x. And then that's we want to know when is that equal to, right? For what value of B, are their average values equal? So in other words, what I really want to do is I want to know where is this true? Okay, so where is this true? So what I end up getting is I get 1 over B equals 0 to B. Cosine 2x dx equals 1 over B, 0 to B of e to the x minus 1 dx. So integrating this, I get 1 over B times, so let's integrate cosine of 2x. So I'm just going to really quickly off to the side, I'm going to let u equal 2x, which means du equals 2 dx, which means 1/2 du equals dx. So I get times, actually let's do this. I'm going to say, let's say times 1/2. I'm not going to put in my limits of integration right now. I'm going to substitute them back when I get back to x's, since I don't have actual numbers here, except for the 0. So I'm going to say cosine of u du, and that's going to be equal to 1 over b times the integral of 0 to b, no u substitution needed. So let's see what we get here. So I get 1 over 2b. The antiderivative of cosine is sine, so this gives me sine u. I'm actually, if you don't mind, I'm going to plug that right back in right now. So u equals 2x. So sine 2x from 0 to b is going to be equal to 1 over b times the antiderivative of e to the x is e to the x minus x from 0 to b. So from here, right, actually before I do, I've kind of done a lot there. So let me just pause for a second and see if you have any questions. Okay, if not, let's keep on going. So I get 1 over 2b equal times, well, the sine, we don't know what b is, but I think you guys would agree I'd get sine of 2 times b minus the sine of 0, which is going to be 0. So I'm going to not have that part there. And that's going to be equal to 1 over b times e to the b minus b. And that's going to be minus e to the 0 minus 0. Now, you might be going, wow, that looks terrible. Your calculator will solve this, right? What I'm going to do for my calculator, and there's a couple ways I can do it depending on my calculator, but I'm going to set one side equal to 0, right? So, and for my calculator, what I would do instead of using b's, right, I'd use the letter x. So what I would do in my calculator, I'm going to graph the function. When I go to graph it, I'm going to graph this. So 1 over 2b times sine of 2b minus 1 over b times e to the b minus 1, right? Because e to the 0 is 1. I'm going to graph that, and then I'm going to look for its zeros. And that's all we need to do there. I could. So the question is, why wouldn't you cancel out some of the b's, things like that, maybe do some algebra? Absolutely, you could. And it might be easier to type it into your calculator doing that. I don't know which would be faster, but you don't need to. Okay, so again, like at this point, this is all in one variable. My calculator should find this easily enough. And again, could I calculate up? Could I cancel things out? Actually, Oh, I see what you're saying. Yeah, I could, if I distributed like that 1 over b, I could cancel some stuff out maybe. I don't know if that would be any easier though. Okay. Any follow-ups on number 12? Okay, then let's look at I may not be able to look at this one yet. Let's see. 7 on part 3. What is part 3? There's a part 3? What? I'm not. So the question was look at question number 7 on part 3. I'm not sure. So that was asked by Emma. I'm not sure what you're asking. 7, also 7 part 3. Oh, it's on part B. Is that what that's what we're saying? It's not a 3, it's a B. It's on part B, but the third section. On part B. Oh, I see what you're saying. Okay, so let me look at number 7. Okay, so so we're just looking at number 7. Is that what we're meaning here? Okay. I was a little bit confused there. Okay. I'm gonna also just grab this. Yeah, let me grab this whole thing. I don't think I need the space, but let's grab it. Okay. So, first thing we want to do is look at our values here. Which of the following statements is true? So, first off, let's go look at each one. So, f of 1. What is f of 1? Well, f of 1 is approximately, so let's see. A graph of the function f is shown to the right. Which of the following is true? So, this is the graph of f. Okay, so f of 1, I think you guys would agree, is 1. Now let's look at f prime of 3. So remember, f prime of 3 is the slope of the tangent line at 3. And I think you guys agree, we may not know it, but it's negative, right? Therefore, f of 1 has to be greater than f prime of 3 because f prime of 3 is negative. So this is true. I'm going to put check marks by the one we know are true. Next. We are looking at the definite integral from 1 to 2. So from 1, to 2. And we want to know, we're saying that's greater than f prime of 3.5. So let me just look what f prime of 3.5 is really quickly, because this may be obvious, but maybe it's not. So f prime of 3.5 looks like it's about 0. Right? The slope of the tangent line is 0, while the area that I've highlighted is obviously some sort of positive number. So clearly, number 2 is also correct. Okay? Finally, let's look at this. So, first off, and this is this right here, you have to recognize. This is a flashcard. It's saying take the derivative at 2. Take the derivative at 2. So that derivative at 2, I think you guys would agree, and hopefully it's obvious, but maybe it's not. It's this. It's that slope of that tangent line. Okay? Now it's saying go look at the slope of the secant line from 2 to 2.5. So 2, I'm going to do this in red. From 2, I missed. from 2 to 2.5. I think you would agree that the derivative at 2, did I miss the derivative at 2? I totally missed it. What's going on there? Let me do a better job. My aim was off. My derivative at 2 was something like this. So let me just kind of blow this up. So a couple questions came in, but let me blow that up. So I think you guys would agree, blue line is steeper than red line. So this statement is true. So all three statements are true. Okay? So let's kind of go back. Let's backtrack a little bit, answer some of the questions. So why are you able to compare area and slope? It's not that I can compare area and slope. Remember, both of these, so this is in regards to this second one right here, I think. Yes. They're asking me which of these numbers, so this right here is a number. I'm not comparing the area and the slope. I'm saying that's a number. In this case, that number was positive. Then this is also a number. That number was 0. So I'm not comparing area and slope. I'm comparing two different numbers that I happen to be calculating using area and slope. Okay? For the second part, how did you know it's a secant line? You have to just look at this. This is your slope formula. I mean, you just have to kind of recognize it, right? That's y2 minus y1 over x2 minus x1. That's a secant line. On mine, I said the third was not true. I think it is, though. So maybe I'm wrong. Let's double check before I mess up here. Let's just make sure. So the first one, we were taking the derivative at 0. Sorry, we're taking the derivative at 2. That is that. That is correct. And then we are going from, the next one is a secant line from 2 to 2.5. I'm betting I just had trouble seeing it. So so the answer should be E. Let's go find out. This should be right. I don't understand how I'd be wrong here. But let's double check. Let's go and make, what problem is this? Number 7. Let's just make sure that I am not making a mistake, that I am not missing something. So number 7 is E. Yeah, so I don't know why on my online I said that. Maybe like in this one, I just drew my secant line wrong or my slope line incorrectly, and that's why I thought that. But that's a mistake. It is definitely E. Okay. Any follow-ups on that one? Because I know that was a fairly popular question in terms of your questions. Okay, let's see. Are there any questions that I missed? Were there any multiple choice questions that I missed? 13 and 15. Okay, let's see what we can do here. 13. Okay, let's see here. So, if a left Riemann sum over approximates the definite integral of that. So a left Riemann sum, so left Riemann sums means we're making rectangles using the left-hand side of each rectangle to approximate. So, and a trapezoid sum under approximates. Which of the following graphs could this be? Okay, so let's see. Left-hand side over approximates. So if I'm using the left-hand side, so let's just kind of break this up into, I'm just going to break this up into like 2 rectangles instead of, however many they want us to do. I'm going to just break each one of these up into 2. So here's my 2. If I'm doing a left-hand side, then rectangle 1 would look like this. Rectangle 2 would look like this. I think you'd agree That's an under approximation. Doesn't work. Okay? So, goodbye A. Let's keep on going, see if there's any others that are pretty obvious like that. On this one, I think you'd agree, if I broke it up into two rectangles, my left-hand side would be over an approximation. So for the first part, this is still a candidate. For the second one, again, still a candidate. D, not a candidate, right? We break this up into two, and that's an under approximation. For the next one, we break it up into two, under approximation. So we are left with which one? So this was no, and these two were yes so far. Okay? In regards to narrowing it down to B and C for number 13, do you have any questions? Okay, then let's go and figure out between B and C. So now we're going to do trapezoids. And I'm going to, again, just do two trapezoids here. So for this one, trapezoid 1 is going to go from here to here, and then here to here. Looking at the second one, here to here, here to here. And you may be going, well, I really can't tell. Those look like really good approximations. But let's kind of look at the, if you notice, and I know this isn't the best way of kind of doing it, but I think you would agree, if you kind of look at I'm trying to think of a good way of explaining this, but visually speaking, I think you would agree that B appears to be, the trapezoids seem to be an over approximation. And my reasoning being that it's an over approximation is if you look at the concavity, right? So let's choose this point right here. So zooming it in, any line from here to here, based on the concavity, is going to be above the curve. Same thing from here to here. So this is an over approximation. This one, if you look at the concavity, right, any line that I draw is going to be below, because this is concave down. So any line that I draw between these 2 points, and again, I don't know, I'm not using actual concavity here, like I'm not using second derivative rules, but I'm just kind of seeing that the lines that I would be drawing because they are concave up, because they are concave down, that's what I'd get. So in this question, what did we want? We wanted under approximate. So the one that would be under approximate would be C. So between B and C, we're looking at letter C. In regards to number 13, are there any follow-ups? Okay, let's look at 15. Number 15. Ooh, okay, what do we got here? I'm going to grab this one. There's no way I have room to do this. Maybe I do. I honestly don't know. Okay, what do we got here? Number 15. The number of bacteria in a culture is given by blank, where T is measured on days. On what day does the rate of change take its maximum value? On what day does the rate of change of N of T take its maximum value? Okay, so. Okay, so first off, let's think about what we're saying, and I want to make sure, the language is a little bit weird on this, but let's make sure we're okay. So this right here represents a position function, okay, because it represents the number of bacteria. Now, the question's asking, on what day does the rate of change of N of T take its maximum value? So in other words, I want to know, when does N prime of T, where does N prime of T have a maximum? Okay? So that means I'm going to be having to look at its second derivative, right? Because it's asking where does n prime of t have a maximum, not where does n of t have a maximum. Where does n prime of t have a maximum? Okay? So because rate of change is a derivative. So where does the rate of change of n of t take its maximum value? So what I'm going to do is I'm going to have to take the second derivative of this. And again, this is a calculator thing. So I'm going to go take the second derivative of this thing. So I'm going to get n double prime of t. I'm going to set it equal to 0. And then whatever values I get, I'm going to make a quick sign chart and plug some values in from there. So whatever those critical values are, values are, I'm going to use that. Okay? Any follow-ups on 15? Okay, if there are no follow-ups, I actually should probably be logging off because I do have a meeting in like 14 minutes. So I do need to kind of get ready for that. Reminder, tomorrow, double checking. I don't want to mess this up because last week I was definitely having problems. So tomorrow, what is tomorrow? Tomorrow's Wednesday. So we're going to be going over problem 10 from the free response packet, and then I'll be having you guys do numbers 14 and 21. So again, tomorrow, 10 a.m. live stream, going over problem 10. I will also hit that problem that I was having difficulty with, whatever one that is. I have it in my notes. So I will hit that one. I'll probably start off with that one, and then we'll jump into number 10. So again, thank you guys for being here. And I look forward to seeing you tomorrow.